Swayam Prabha. Digital India. Educated India.
Hello everyone and welcome to this new topic, that is GIS Analysis Part 4. Here we are again, this is also a kind of neighborhood operation, but we put them as in a completely separate category, and that called the buffer analysis. It has got lot of applications and we will see how this works, what are the advantages and limitations also. So, basically it is a combined function which is a search function in the neighborhood, and again based on certain criteria or conditions we put while creating a buffer, and buffers can be created around a point or polyline and polygon, etc. So, what basically when we go for a buffer analysis, it would create an area expansion, widen the area of the feature may be point, line or polyline or polygon, and then we can visualize as the spreading object, especially by a given distance, and this given the distance we have to provide as user, we have to provide that in how much expansion in a particular feature we want. For example, I can do the buffer analysis or create buffers along my 3 input points like these circles. So, in middle stage of buffer analysis, 3 circles of radius, different radius may be created. Now, this different radius values will come in from one of the attributes, and suppose there are against each point I am having certain information about say pollutants. So, how this will be there, and so the point in which the more pollutions there, it will have a larger radius and others would have less. And in the final stage we can go for a dissolved type, and here dissolved type is none, dissolved type all. So, whichever is overlapping circles will be dissolved, and then you get something like this shape. Now, similarly for polyline or a line feature, this is how the buffer will be generated. That buffer is generated along this line and in the surrounding. So, basically a circle is drawn like this using this point as a center point, and then again if we go for this dissolve type option, then it will dissolve something like this. Similarly for polygon, the same way it can be done, and then so this width which we are talking is basically the expansion of a feature. Now, it may be one example I have given about the pollutants, it may be related with groundwater extraction, it may be related with oil exploration or oil extraction, or any other feature, or along a road also, that we want to know who owns the land along a road, and if we want to create say 500 meter buffer, then that can be created. And once we are having say this kind of polygon, then I can overlay this polygon over the revenue records and can extract information about the owners of different plots below this buffer. So, that overlay operations can be employed there also. So, buffer has got lot of applications, and this is basically say expansion, also sometimes it is called offset of a line. Example here along a line, how along a line or polyline buffer is created, as I was mentioning in the previous slide, that a circle are drawn here because this is the end. So, half circle is drawn here, this is the within the polyline. So, the full circle is drawn, and then finally these circles are connected like this, as we can see here. So, input is the line feature, then offset or expansion is decided by the user depending on the understanding about a particular requirement of phenomena, and then buffer can be generated like this. Similarly, for buffer zone determination for using point data, that can be done if we are having the rainfall information about certain points. I can do that calculation, I can do the distance calculation, and finally I get the distance around rainfall stations, that it is expected that the rainfall, the value of rainfall would be more closer, more as per input, but as I go away from the station, that uncertainty is not there, but still I can generate buffers like this. So, for different kind of analysis, buffers can be generated quite easily on a GIS platform. Now, there are some little different techniques, variations within buffer technique is there and are there. For example, buffer infusion, infusing extended GIS procedures in a generating buffer. We may create buffers using some impedance. For example, if I am studying a pollution which is say point source pollution coming out of a chimney, for example, now I want to create a very realistic buffer by implying not only the distance or dispersion distance, but also I would like to involve the wind speed and direction. So, for that I can infuse some other GIS procedures to create more realistic buffers. So, by using such impedance. So, everyone which relates to the concept of within or fill in the distance of a stream neighborhood or critical habitat area, all there we can do this buffering. And they basically this, as you have seen, that this concept involves a circle or concentric ring about a feature, and that has a rich heritage in the manual map processing. So, in that way we can create buffers. Now, for example, we can have a division of a simple buffer into uphills and downhills components can also be can be used or generated, and such applications are useful for the road journey or train journey. And these are like civil engineers, those who are related with transportation engineering would like to understand all this before any such thing is planned or during the planning operation or before the construction, that road engineer sees different land slippage considerations in two areas, that is up and down slope in a hilly terrain. Environmental scientists whereas would be concentrating on downhole portion for flow of sediments. Same with the those who do the erosional soil erosion studies, and the same may be the hydrologist who are looking how the water is flowing and how much sediment it is carrying. So, this is downflow and slope analysis, and other chemicals or elements in the water might be there. So, in most applications the consideration of characteristics and conditions within a buffer are at least as important as outline of its extent. That means that not only the extent is important, but other impedance which will allow us to create more realistic buffers, and that is to generate such outputs one has to have a good understanding about that particular phenomena, and then we need to have that input also, and then we generate more realistic buffer. If I take back again the same example of your pollution studies coming out of a point source, then in case of air then it is a 3-dimensional space. So, I have to consider not only the wind direction speed, but how within the depth of atmosphere, near surface atmosphere, how things will vary. And so, that means the temperature might also come, whether the wind speed I am taking is throughout the column is same or different. So, as we go for more realistic, higher and higher real scenarios, we might be requiring more inputs and better understanding about that particular phenomena. But it is possible, it is being done, and lot of such modeling work is being done using buffers along with combining with some other GIS operations, especially like overlaying operations, etc. How buffers works? You can have a fixed distance like a buffer of a line features, which so far the examples which we have seen all where the fixed distance using a distance of 20, and then n type may be flat. We can put all these options during the buffer calculations, and finally we can say that I want dissolve type. So when we do all, we put these conditions. This is how, for an example, this is my input which is a polyline, and this is how the buffer has been created. Finally these have been dissolved all, and this is how I see the output. So for a road network or a street network within a city, such kind of buffers can also be created. Now this as buffer distance is in this example is constant, all features are buffered to the same width. But if this is not constant, it is varying depending on, say this is the road traffic. So I want where more traffic is there, I want wider road. So how, if widening has to be done, which part has to be done, say within this example. So from that means that from where that value will come, for instead of constant value I want a varying value. So definitely that varying value is going to come from one of the attributes. So here the conditions are that the values will be, in the previous example there were fixed width. Now here values are varying 10, 20 and 30 from the center of the road. N type is flat, that means it is in the flat terrain, and for all sides I want the full, means all sides there will be expansion or buffer generation, and it is dissolved type. So if we take the same example as previous one, but having different attribute values 10, 20 and 30, and therefore using those values, there is attribute values as the width of my buffer, I can generate something like this. So instead of that first example, here I am getting more realistic example. Here because of every phenomena may not require, may not have a same kind of requirements for the width or expansion. So if I talk here about the say traffic point of view, then here it is more traffic is there, or maybe more pollution is there. So depending on that, I may have that information as one of the attributes. While creating buffers, I can use the varying expansion width or distance and can calculate the more realistic buffer than the previous example. Now here in this one, as the buffer distances are dependent on the field values, that means one of the attributes, the various buffer width can be, as you can see here, the three types of buffer width have been created using the same operation as we applied in the previous, but there we kept only the fixed width or fixed distance. Here we are having other parameters are same. No changes are there, but still we are getting different outputs because of, instead of fixed width we are getting now varying width as per given attributes. So we have already discussed some applications of buffers, but for completeness we will go one by one. For soil erosion studies, buffers are very useful, or any other type of erosional studies, buffers can be generated and the situations can be assessed. In landslide studies also, buffers are very important to know that which are the areas which are initially going to be affected, then later on and so on, how a landslide will expand in future depending on the, of course, the terrain characteristics and other like vegetation cover, land use, soil, lithology, but along with that terrain characteristics. So all these, if that information is there, we can create a buffer along existing landslides, and these buffers will let us know how it would expand in future if things continues in the same way. Similarly, in case of earthquakes, buffers can also be created about the damage, that how the damage has occurred. Of course, there is a completely different concept about assessment of damage, which is based on the Mercalli scale, and about which is called the intensity map. But there also the buffers are created. You can employ GIS to create those buffers. Of course, the input has to come first from the field if we want to create that intensity map of an earthquake. In many environmental studies, including in pollution studies, buffers are very, very important to analyze. In telecommunication also, especially in mobile communication, that a tower, as you know, that it is the transmission or the connectivity is not in a circular form, it is having an angle. So, suppose there is a tower located, then it might cover only this much area, not like this. Now, so while putting, if there is a gap, then probably one more tower is required here to cover this much area, and so on and so forth. Of course, depending on about the users and other thing. So, nowadays these mobile agencies or mobile operators, they are using GIS extensively, and these buffers technologies along with these overlaying operations to know where the gaps in the mobile signals in within a city or a town, and those gaps can be initially can be analyzed, and then installing a new tower, and these gaps can be filled. So, there is a large application of buffering techniques of GIS into telecommunication also. Power supply, especially in hydropower, there also buffer, because we can analyze that how much loss in the power will be there if the energy or the this power has to be transported to a large distance. So, from that point of view, buffers can also be generated, and these things can be estimated even before a power line is put in the field. So, these analysis can be done. This is non-exhaustive list, and this will continue. More and more applications of buffers are coming. People are trying to explore the possibilities how to use these buffer technology of GIS for their own purposes. Now, one more analysis which we can do, which is not at all directly linked with buffers, but it is linked with the terrain. And this is in some literature you may find earlier we used to say view-shed analysis. Also now it is a visible area for a rugged terrain or hilly terrain. So, what basically in this analysis what we do, we determine the visibility of an area from a particular point or a set of viewpoints. For example, if I say that somebody is about to construct a hotel in Mussoorie, and he would like to assess that how much Dehradun valley would be visible from top floor of his hotel, though the hotel is not yet has come. But all these things can be modeled, can be analyzed using this view-shed analysis. View-shed analysis are having applications for various purposes, from security point of view, from mining operations, and for many other operations also, including in your mobile tower, including laying of power cables, etc. So, view-shed analysis can also be employed. What is the input layer here? The input layer generally is the elevation values which is there, and which is used for the planning locations of surveillance facilities such as fire towers or transmission facilities, power lines, and etc. Or just for in the forest also they use, where they put the some tower to see even the wildlife and others, and overall the forest conditions as well. So, here what you can see, that is a terrain in this schematic is shown. A person which will become offset, his height will become offset. So, that has to be added in the height, whatever the height of where he is standing above mean sea level, how much distance he can see, and what is the angle which he is having. All this will allow us to know that like this area will come in the shadow. So, a person is standing here will not be able to see this this much of area. Similarly, the same person after this peak may not be able to see this area either. But for him this area is visible, for him this area is completely visible. So, this I have just discussed in terms of 2D or in a profile section, but the same analysis can also be done in terms of 3D, means for all around, not only in one direction. Here it is shown only in one direction, but in all directions it can be done. Like here, and this is the screenshot of ARC GIS analysis. The person or offset is given here, the person is standing here or a tower. Now from here we would like to know, and also one more here, for this area the analysis has been done, for this area the analysis has been done. It is not necessary that entire circular area should be covered, but if we can restrict that only in a particular angle I want to see or arc I want to analyze. So, all green areas are here the visible and all other areas are not visible. Now, if there is a choice of increasing the offset, if we can do that, like raising the height of a building and before during planning process, then if we raise that, obviously the visible area will become much larger. So, such analysis before anything really happens on the ground can be done very easily employing this technique of GIS, which is view shed analysis. Another example in a circular fashion, that if a person is standing here, if he rotates, how much area would be visible and how much area will not be visible. So, these green areas again are visible, red areas are not visible, not this area, but so remaining areas are not. This green, this red is because of these lines which are concentrating all around the points. And see in this line of sight or view shed analysis, lot of parameters a user himself can control. So, the impedance and other things can also be provided here. Impedance, maybe this area might be forest cover. So, if we know the height of the trees, an average height of the tree, that impedance we can put, and of course, the terrain is already there. So, that information plus the adding the height of the tree, also adding the offset value of height of a person or a building or tower, we can create a more realistic picture or a view shed like this before really anything happens on the ground. If you recall the definition of GIS, in the last it says that it allows to do the modeling. Modeling means prediction, and prediction, that means nothing is happening on the ground. We are trying to model it, predicting it, how it will happen, how it will look, and that way GIS and especially this technique for view shed analysis is really very powerful technique, by which we can exactly know how once this building comes or this tower comes, how much area would be visible from top of that building or middle or wherever you want to analyze, that can be done. Of course, as detailed input information is available, not only the digital elevation model, but other parameters, if those are impedance which are available, more realistic scenarios can be generated. So, this brings to the end of this discussion about the GIS analysis part 4. We will continue on this GIS analysis in next lecture. Thank you very much.